Good evening, friends. Today, in this session, we are going to learn how to create a data frame. And before we can actually start creating data frames, we must understand what is a data frame and how it is useful for storing data and analyzing data. Now, data frames are basically, we got two-dimensional structures, and these data frames can be perceived as an Excel table where we have got rows and columns. And if you can see a visual data frame here, we can see that these data frames have got data in the tabular structure where we have got column names, sometimes called column labels, and row indices. So these two-dimensional data structures store data in the form of records, and basically they are acquired from various large data sources. The data for the data frames are acquired from large data sources, and we use them for data analysis. Now, these data frames are two-dimensional and size mutable, and they can have heterogeneous tabular data, and they are in the form of rows and columns. Now we can also perceive data frame to be a kind of a spreadsheet having rows and columns where data is stored in the cells of the intersection of a row and a column. Now, data frames are widely used in data science, machine learning, scientific computing, and many other data intensive fields. On practical purposes, data frames are created from large data sets in the form of CSV files and SQL databases. Actually, we do not create our own data frames from scratch. We acquire data from CSV files which are already available. And these data is then used to create a data frame, and the data in the data frame is analyzed and for scientific purposes. Now we can also create our own data frames from scratch, and we can use a list, dictionary, or series objects to create data frame. The function to use data frame is Pandas data frame function, and it has got a few attributes, and we will be using a few of the attributes like data index, which gives you the list for the index levels and or the row levels, and we have got columns which gives you the labels for the column headers. And d type is optional, we can change the d type if required, but copy and d type are generally used for specific purposes. We'll not discuss these two at the present moment. Now we can perceive a data frame to be a two-dimensional array. Those who are having idea of arrays, we have got arrays having two-dimensional with row and column indices, and we can access each element of our array by indexing of the row, zeroth row and zeroth column will give you the first cell, and so on. We can see that there's a 2D array. I have actually, it's a image of the 2D arrays here for you to refer, and the data frame is similar, but in a data frame we have, apart from this in the numeric indices, we have got labeled indexes. So we have got name for the column headers as well as row headers. We'll see in a short time from now how we can create them. Okay, and again, as I showed you a data frame, an example of a data frame where we have got column names and index labels available for the data. Now, data frames has two indices. One is called the row indices. The axis is 0, and the column index, the axis is 1. And each index can be comprised of numbers, alphabets, or string. So this indices can be either numbers or alphabets or strings. And we can have that data across columns can be of different types. See, you can see that here height is having data which is from the domain of heights, the numbers. We have got range in the domain of some mountain ranges, and we have got coordinates in the domain of that coordinates of longitude and latitude and so on. Okay, so uh, we can in a data frame we can add our own rows, we can delete rows, we can access rows, we can slice a database data frame, and well, many operations can be done. But in this particular session I'm going to talk about creating data frames from scratch. Now we can create, as I told you, that data frames can be created by many ways. This is one way. First way is to create a data frame from using a dictionary. Now if you want to perceive a data frame to be uh, to be actually columns. See, these are columns. Roll number is a column where we have got the roll numbers. The name is a column which is having names, and marks is a column which is having marks. So if you want to perceive a data frame as columns, then we use this method where we create a dictionary of our data, where the keys of the dictionary, actually acts in the data frame as the column headers, and we can have data as a list. Every key has a list in this data, in this particular dictionary. You can see that there are three lists of data, and every such list is basically the comprises of a column. It comprises of a column. So 101, 102, 103, 104, 105 is a column, and that column is basically headed by the that column level roll number. And after we create this particular dictionary, we pass this dictionary to the data frame function of the pandas library, and we see that the data frame is created. Now we see here in this data frame that the indices are by default from 0 to that is 4, and the column headers are roll number, name, and marks. And I should tell you here that the columns can be accessed as not only with these names but also with the numbers. So if I don't give, if you want to, if you don't have this column headers, we can see that these data frames have this default the numeric index also. We'll see later data frame creations that we have data frame with index numeric indices and numeric that is row that is column levels. And now this is one data frame that doesn't have row indices and labeled. We can add this row indices by using the index attribute, setting the index attribute with the list of indices, and the number of indices here should be equal to the number of rows that we have used for creating the data frame. And now after you execute this particular cell, we find that the indices in place of numbers we have got S1, S2, S3, S4 and S5 are the indices for this data frame. This is the first method of creation of data frame, where we want to perceive the data in the form of columns. Now if you want to perceive data in the form of rows, okay, now I want to perceive the data in the form of rows. So this is my first row, this is my second row, and this is my third row and the fourth row. So if you want to perceive data as rows, we use a nested list to create the data frame. So here we have got a nested list where each sublist comprises of a row. So 10 Ashok M is the first sublist, and it comprises of the first row. And similarly 20 Ravi and M are the is the second list, comprised of the second row, and so on. So we have got 4 rows here. Then I have added here the index and the columns attributes to give the numeric to give the actually named indices and named column labels. I can see when I do this. Let me kind of comment this and see how the data frame look like. So it's you can see that after we literally comment this, and we see that we have got the default numeric indices for rows as well as columns. So it is a choice of the data frame creator for what purpose you want to create the data frame, how you want to basically store the data, whether you need a column level, whether you need a row index level. That's up to you. So it's up to you, and then based upon your requirement, you can create your data frame. Now, this is the second method where we are perceiving the data to be rows. The third way of creating a data frame is to have a list of dictionaries. Here I have created a data frame using a list of dictionaries, where the dictionary keys will become the column headings. You have to be careful about while creating this particular data for the dictionary. You see that all these 3 dictionaries here have same key sets. Can you see this? Same keys: A, B, C, and D, A, B, C, and D, and A, B, C, and D, and having different data. Now, when you create a data frame from this, we see that all the keys form the column headers. All the keys from the column headers, and we have, since we have not provided any index for the rows, so that's why the rows are coming as default numeric indices. This is the third method of creating a data frame, where we can create a list of that is the list of dictionaries, and pass it to the data frame method to create the data frame. Now here what happens if I by mistake or by choice I don't have the data frame that is similarity in the data frame that is this dictionary that is keys for these data frames. So I have got A, B, C, and F here. Here I've got A, B, C, and D, and I have got A, B, C, and E. Now they are not similar. What will happen in this case? It will not create, it will not throw any exception. It will still create a data frame. But in this data frame, we can see that we have got additional columns. These two columns are we've got additional column F and basically E are additional columns, and this number of columns for this particular data frame will be the unique count of that is key values in this list of dictionaries. Unique, well, the number of unique keys in these dictionaries will be forming the column levels for this particular data frame, and then the data will be based upon the intersection of the rows and columns, and if there is something which is missing, so for the zeroth column, zeroth row, there is no value for D, so that will be replaced with NaN or not a number. So this is the adjustment data frame automatically creates while creating a data frame from a dissimilar set of dictionaries. These are dissimilar set of dictionaries where there is non-matching keys. Keys are non-matching, not matching. If we can, if we see the previous data frame where the keys were A, B, C, and D, here in two data frames we have got two different keys, and that's why NaN has been automatically introduced. This is the third method of having the data frame for our purpose. The fourth method is something which is a little bit trickier, where we are having a nested dictionaries to create a data frame. This is the nested dictionary where we got data as four dictionaries: year 15, year 16, year 17, year 18, where we have got similar kind of keys for all the four dictionaries: Q1, Q2, Q3, and Q4 with certain data. And we create a dictionary sales from this particular dictionary. These four dictionaries will be the values for this particular sales dictionary, and we have something called for this four that is years 2015, 2016, 2017, 2018 as the keys for the dictionary. And you see that in this particular arrangement, the inner dictionary keys will always create the index levels, not the row, not the column levels. The inner dictionary will create the index level, and the outer dictionary will keys will create the column levels. As you see that I have created a dictionary here, that the outer key becomes the column names, inner keys become the row indices. You can see here, this is how this data frame has been created. Can you see this? Now this data frame creation has a very interesting feature. Now if I create a data frame, a similar data frame I am creating, but here only numbers are there, I am creating a still more intelligent data frame having records. Now roll number, name, and age are the for actually constitute the record for S1, and roll number, name, age is for the second record, and third record, and fourth record, so on. Now the same thing we have done. We have created this dictionary, and which nests the four S1, S2, S3, S4 dictionaries, and then we see how it has created data frame. Now we see that in place of a columnar data, this data is in the row. You can see the earlier dictionary either data frames, the data we perceive as columns. Generally we data is perceived as columns. Roll number is a column, name is a column, marks is a column. But in this case you will see that the data frame, the row consists of a column. Can you see? Row consists of column. No consists of the data from a single domain. It has kind of just transposed. The data frame has transposed from rows has become columns, and columns has become rows. This is how this kind of arrangement creates a data frame. So you'll be very careful while creating a data frame using this method. If you want a data frame to have that is data which is set as kind of columns having a record. Student 1 is a column, it is having a record. Student 2 is a column, is having a record, columnar records. And generally we don't save it this way. We don't create it this way. We create that columns have basically data from a same domain, and rows are having records. Rows are having records, but in this case we find that that it is transposed, and a transposed data frame where we see that this data which you have created is actually the columns are having records. This is the second method. This is the fourth method of creating a data frame. And in this say in this case also, if you have dissimilar keys in these four data frames, if we have dissimilar keys, then we have additional rows in the data frame. Can you see the additional rows here? These additional rows, and these additional rows will have non-matching cells to be filled with NaNs. Non-matching cells to be filled only if you see the 2016 QT2. 2016 QT2 is having data 7200. Others are not having data. So this is the data which is filled here, 7200, and all other rows for all other columns that it is filled with NaNs. So this is how data frame is created while using this method. This is similar to the earlier method which we have studied, where we are using a list of dictionaries. There also NaNs are created. Now, the last method of creating a data frame is by using a series object. So I have got a set of index here, index, and these are the indices for the data frame. And I have created a series object as hobby, having hobbies, and its index is ind, which I have created a level such a list of indices. And then we have got another index called another data frame called marks, and it is another series object having some marks with the same index. And then I have nested them to create a dictionary. So this is the hobbies dictionary, this particular series, and marks is this another series, and I have created a dictionary out of the two. So hobby is one dictionary here for us, and marks is key for hobby is one key for us, and marks is one other key. And this hobby is a series, and this hobby is a series. Then we create a data frame, and I find that this data frame is created where this data from the series is placed under one column. The one column is having the data from one series, the other column is having the data from another series. So these are the this is another way of creating data frame. And the last way of creating data frame from scratch is to use a existing data frame. So I have got a data frame here, and having everything that indices, columns, and data for the rows. And we create a new data frame, and pd.dataframe, and we pass the existing data frame as a parameter, and then the new data frame is just a copy of the earlier data frame. So students, we have now learned various ways of creating data frames. Now I wish that you take this particular assignment and create your data frame using this data which I have provided, and use all the methods which you have learned to create your own data frame. Thank you very much for patiently listening to this particular lecture, and hope that you have understood how to create data frames from scratch. Thank you very much.